This is the question I'm asking in this video. Can we make composable embeddings to generate full sentence embeddings? So composable embeddings, I'm saying that individual sentences or smaller parts of these sentences or words merge those embeddings to make the original big sentence embeddings. And we could store this in the individual words or smaller parts of the sentences in a vector database. We could just search them and just combine their embeddings. Let's find out that if this method works or not. There is still some problem. If we go this route, there will be a contextual problem. For example, which part is before what? And if there is some dependence, we could not know which is before what. If I break the sentence, it does not exactly generate the original embedding. So this is the question I'm asking in this. Can we do vector arithmetic on the embeddings? I will show in this video clip embeddings. So embeddings here can be image embeddings or text embeddings. In this video, I have only worked with text embeddings, but since clip maps both text and image in the same latent space, so if I manipulate one, then it should translate to the image embeddings. And now here I'm showing the text and image embeddings, and they're matching probability and cosine similarity. So the image that I have input is from Albert Einstein, and these are the text that I'm comparing against. So my image embedding will be from Albert Einstein image. It is clearly seen that if I look at the cosine similarity, the Albert Einstein one with the Albert Einstein text matched most with the image of Albert Einstein, even more than the word a man. In this part, I have a text list of various texts to match against. So I have done a hook to actually, it is for my own experiment to see actually how many maximum tokens MobileClip used. So I found that it uses the same maximum limit of tokens as the original clip model, so which is 77. And I have found that same value is mentioned in the MobileClip paper. Here it mentions the context length as 77, same as the original clip from OpenAI. Here are the sentences that I'm using for comparing against the images. This part is actually where I'm doing vector arithmetic. I have combined the first and the second text to make another text that should match the image more closely. As it can be seen here that the maximum match is with the best match, but our composable embeddings can get the third place. Now if I remove the best matching sentences like Albert Einstein with gray hair man, and if we do composable embeddings, as you can see that this is the maximum match, but this was nowhere in the text. It was made merging two text embeddings, the first one and the second one. It did not exist in the input. Now what I'm doing is I'm merging the first three texts from the text list. So merging the first three means gray hair, a man, and Albert Einstein. As it can be seen, it did not take the first place. Actually, it is in the third place. The first place one is the original text embeddings from the full sentence. And in the third place is the composed from three embeddings added. But it can be seen actually that it is actually working. Even though the merging is not that great, as I understand, specifically not trained for this. Now if I use another image from inside a car, it can be seen that none of this text match with the car. All have low values for cosine similarity score. Now if I add text describing the image, for example, if I use add 4 new text, for example, driver, steering wheel, car, and mirror. First, I will use this without any vector arithmetic. So I have disabled all the merging of embeddings, and I'm only testing the text list that is present. So the image matches with the text car the most, and steering wheel in the second place, then driver, then mirror. But if I combine all four of these text, can it beat the other text? So I'm using the first four text from the text list. As it can be seen that the match, actually it matches the most between all the text list. It is in the first place with the highest similarity, even though it is not very far from car. So in a way this is working, but does it actually work on, for example, text to image methods? That is a question that can only be answered from testing with this method. Now I've moved into text embedding with a text embedding model. So for this I'm using the GTE Base version 1.5. I'm using the ONNX model variant. So I have matched the first and the third in the text list. I don't know why it matches. For example, a dog with table has a strong match in cosine similarity. But if I do, for example, if I minus the embedding from the first to the second and compare it to the third, it goes into the negative. Now this part is important. I am merging the first four text from the text list and comparing with the fifth one. So as it can be seen, it has a good match. So I'm merging a dog, a cat, a table, and sitting. These four sentence embeddings merging into one and comparing it to the sentence a cat and a dog sitting in a table. Now I'll stop talking for the rest of the video. Feel free to share your insights on the comment section. If you have any further ideas to improve this method, feel free to share that too with us.